In this video, I would like to talk about vegetation indices and how they can be used to analyze crop health, and then how to practically do it in Solvi. But before we dive into that, it's important to understand the concept of reflectance. So as you may know, sun emits the light, and this light is reflected by all the objects on the ground, including the vegetation. And there are different parts of light, also called spectrums or wavelength. There is visible light, red, green, and blue, that we humans can see with our naked eye. And vegetation typically reflects about the same amount of visible light, a little bit more of a green light. That's also why it appears as green. But there are spectrums of light that we humans can see. So spectrums like red edge or near-infrared or thermal. And the differences in reflectance in vegetation are much bigger there. That's why this data can be useful for crop health analysis. And the drone cameras capture exactly that, the reflectance, and it's typically expressed as digital numbers, so simply like a number stored in each pixel of the imagery. Images also consist of the different bands or layers, so each band typically represents a specific spectrum of light. So there is RGB imagery that measures red, green, and blue light, and there are multispectral sensors that measure those additional spectrums of light not visible to our human eye. And the data format that they use is slightly different, and multispectral sensors typically use a much richer data format, 16-bit data type that can store much richer data. It's also worth keeping in mind, if you're working with different multispectral cameras, that different cameras measure slightly different spectrums of light. So even if specifications say that the camera measure, for example, near-infrared light, the exact wavelength that it measures can be different. So when comparing the data between different sensors, it's important to be aware of that. So now we can dive into vegetation indices. What are they? So they're simply a mathematical formula that uses data from the different bands and applies different equations to them to calculate a health score. And typically it will be a number between -1 and 1, and the higher the number, the healthier the vegetation is. And there are hundreds of these indices. Each of them correlates differently with different traits of the crops. So there are indices that are linked to amount of biomass, nitrogen levels in the crops. Some indices can help reveal potential disease hotspots, and so on. So in Solvi, we provide the tools to easily calculate these indices for the whole fields, but also for small plots in field trials, and even for individual plants in our Plant AI tool. And in the next step, I will show how to do it practically. Now let's have a look at how to calculate vegetation indices in Solvi. As an example, we can take this potato field captured with MicaSense Alto multispectral sensor. If we look into the settings of this field map, we can see that right now we're looking at the visual version of it, red, green, and blue RGB imagery. But the sensors also captures red edge and near-infrared bands, and we can toggle between those bands and can clearly see that there is quite a difference in what we see in those different parts of the light spectrum. Another example, a bit more advanced sensor, is MicaSense triple sensor that captures 15 different bands. If we switch over to the settings here, we can see that for every part of the light, we have several wavelengths to choose from. So this is very suitable for more advanced research, where you can look at the very, very specific spectrums of light. Then this data capture with this sensor can come very handy. So back to our potato example, let's have a look at how to calculate the indices. So to create a vegetation index map for the whole field, we will simply switch to the Analysis tab and toggle the Plant Health tool. And as we do that, the default index will automatically be loaded. In this case, it's NDRE, an index that uses NIR and red edge bands. But we can easily switch to any other index, and there are 10 indices available by default in Solvi for all users. So to see what another index looks like, we simply switch to it, and here we now render the NDVI map. And as we do that, also we can see that there is a histogram here that shows the distribution of all the index values throughout the field. So we can see how much of the field has green vegetation and how much of it has dead vegetation or no vegetation at all. So this tool can be very useful in visualizing the index data. And then if we want to download it, we would simply go to the export tab and download the plant health map either as raw index values for further analysis or a color classified visual image as we see it here on the map. Vegetation indices created for the whole field can also be useful for prescription files. So if we, for example, want to do a fertilizer application based on these variations in the imagery, we can simply create a grid like this in the prescription tool and then download the prescription file in a specific vendor format. So that's vegetation indices on a field level. But now if we dive deeper, if you're a researcher working with small plot trials, you probably want to calculate these indices for the individual plots. And this is an example of an RGB dataset in which we already clearly see that there is difference between the plots. Some are greener, some are not. And to quantify that, we would like to calculate an average index for each individual plot. And that can be easily done with the Zonal Statistics tool, which provides the workflow for quick boundary creation for the whole field trial. And then once we have the boundaries of these different plots, we simply go to the settings and choose which vegetation indices we want to calculate for each individual plot. Once the indices are calculated, right now we're looking at the vary average values. We can see that the plots are also automatically classified, so we can easily spot the plots with lower values and the plots with higher values. And then a third example, if you want to go even deeper and look at the vegetation indices on a plant level, a typical use case would be when analyzing health of the trees in orchards. So that can be done using the Plant AI tool that trains AI model to detect different types of crops, including the trees. And during that workflow, a user can choose which vegetation indices to calculate for each individual tree. So in this case, NDVI index was chosen, so we can see this health score of the individual trees. And similar to the field level plant health maps where we saw the histogram showing the distribution of the index values. Here we have a similar histogram that shows the distribution among the trees, and we can easily see how many trees we have with lower index values, so potentially unhealthy trees, and higher index values. Now, the most common vegetation indices are available to all Solvi users, but as I mentioned before, there are literally over 100 indices that can be more useful in more specific use cases. And to add them to your Solvi account and use for index calculation, there is an index library available here in the top menu that we simply can open and add additional indices from the database that we already have created in Solvi. So here we have about 30 additional indices that can be useful for different use cases. We can see here which spectrums of light they use, what is the formula for the indices, and a brief description for what they can be good for. So let's say, for example, if we want to use this excess green index that is useful for delineating usually vegetation from the soil. So we simply select that index and click Add. And now it appears here under my account, and we can go over to a dataset and use that index. But there are some indices that are not in the library yet. So if that's the case, it is also possible to create a completely new index from scratch. As an example here, I found a PSRI index, Plant Renaissance Reflectance Index, that uses red, blue, and red edge bands. So the formula is red minus blue divided by red edge. So we can easily add that to the account's own index library by simply providing the name and the formula of the index. So I'll just copy the name here and click Create New. Paste in the name here, the short abbreviation over here, and then provide the formula. So that's red minus blue divided by red edge. So as you notice here, we use the reserved variable names for the different bands. So R stands for red, B for blue, and E for red edge, N for NIR, and G for green. And as we input this formula, it's validated, so everything is good. We also get a preview here on the map of what the map looks like. And then we simply hit create to create this index, and it now appears here in the list. So now if we head back over to the potato dataset and just reload the page, we can go to the Analysis tab, toggle the Plant Health tool, and now we should see our index over here. So here is the PSRI index. So we simply toggle that index, and it's automatically recalculated on the fly and shows us this index map. So I hope you found this video helpful and now have a better understanding on how vegetation indices work and how to use them in Solvi.